Welcome to the Twin Cities section video explaining our Future City Competition Special Award for the most creative and innovative use of automation and instrumentation in your team's City of the Future. First, let's quickly review what we're going to talk about today. We'll start by defining automation and instrumentation. We'll follow that with a brief explanation of the technical side of automation and instrumentation to give you some insight into what it's all about. Then we're going to show actual working applications of instrumentation and automation systems in use every day around the world. Then, the fun part. This is where you and your team start to imagine how you would implement automatic systems and instrumentation in your City of the Future. Now, let's get started. Automation and instrumentation, often referred to as simply industrial instrumentation, has been around for centuries, but has only been in the past 50 or so years that it has seen such explosive growth and widespread use around the world. Industrial instrumentation is defined as the art and science of measurement and control of process variables within geographical, production, or manufacturing areas. Typical instrumentation systems usually consist of three parts: sensors, controllers, and final control elements. A huge variety of sensors based on different technologies measure one of 5 physical parameters. They are flow, pressure, temperature, level, and analytical properties. The sensor electronically transmits the measurement to the controller, where it is either recorded or processed for further action. The best way to illustrate this will be with our first example. But first, all automation and instrumentation is very carefully engineered and calculated, relying on expertise in the subjects of mathematics, physics, chemistry, metallurgy, engineering, and design. But these are subjects best left for your school classroom. A number of years ago, Minneapolis was voted the most automated city in America. This is an example. Watch the stop sign. See the lights start flashing? A motion sensor located below the sign detected a car approaching and sent a signal to the controller at the same location. The controller made the lights around the sign start to flash to make the sign more noticeable and stand out. Therefore, make it safer for pedestrians and cars backing out of local driveways. After the car passes, the controller stops the light flashing. Another Minneapolis automation feature is the strobe lights found at stoplights that start flashing when emergency vehicles approach. This warns other drivers of the approaching emergency vehicle. Like our stop sign example, automation is critical to infrastructure support, transportation, and helping to coordinate police, fire, ambulance, and traffic control. In Germany and Arizona, a van outfitted with a high-speed GPS-connected road-scanning laser sensor travels the major highways, scanning for road faults. When one is found, it transmits the location back to the central maintenance shop so that a repair crew can come out and fix it. Water treatment plants and municipalities are major users of industrial instrumentation and automation. Analytical instruments, flow meters, and pressure transmitters continually monitor your drinking water to ensure its safe delivery to our homes. Automation allows workers to be sure that raw sewage is properly treated, minimizing pollution. In buildings, automation and control has existed for decades in the form of building controls, sensing things like air quality, airflow, air temperature, humidity levels, monitoring for fire safety, break-ins, and gas leaks. Automation helps producers deliver quality, low-cost food. Inland fish farms have automatic fish feeders, motor and pump controls, and computer screen graphics to help the operators manage and protect the fish. The cost of butter is kept down, and the quality is maintained thanks to automation. Loaves of bread are ready for shipment by being packed by robots, allowing workers to be used for more interesting work. In the area of agriculture, drones are now used. They automatically fly over farmers' fields, GPS-controlled video scanning the field with near-infrared cameras. The images are put through special filters and then relayed by satellite and stored in the cloud. The resultant images can be viewed by farmers who can see what areas need watering or fertilizing and help them be more efficient. In Brazil, robots are used to plant seeds automatically in the fields, while other robots help harvesting, and yet others travel alongside trees measuring their circumference. In grain elevators, like along Hiawatha Ave in Minneapolis, instrumentation is used to measure grain levels in the silos and keep workers out of unsafe conditions. Some of the biggest users of instrumentation and automation are continuous process industries, pulp and paper making, oil refining, mining, chemical storage, and almost anywhere else you can imagine. The oil sands in northern Alberta at the Canadian end of the proposed Keystone Pipeline is starting to use automatic remote-controlled dump trucks for moving mined bitumen to the extractors. Industrial instrumentation helps ensure quality product while keeping workers safe. A final example is Swatch, the watchmaker. Yes, automatic assembly can displace workers. However, at Swatch, the former watchmakers were retrained and now they build and maintain the robots. This ends our presentation. Thank you very much. Have fun, good luck, and let that creativity go.